In this episode of the On.NET Show, I'm going to have Clement and Christian joining us to talk to us all about all the things that are happening inside of Azure Service Bus. Welcome to another episode of the On.NET Show. So my name is Cecil Phillip, and I have two special guests that are joining me today. So today I have Clemens Vasters, and I also have Christian Wolf. How are you guys doing today?
Good.
Fabulous.
Doing great? Well, I'm so glad to have you guys on.
Yes, thank you for having us.
Yeah, thank you for having us.
Why don't you tell our audience a little bit about yourselves and what do you do in your respective roles?
Okay, I'll go first. My name is Clemens. I'm an architect and I'm in the messaging team.
Okay.
The messaging team owns Azure Event Grids, Azure Event Hubs, Azure Service Bus, and the Azure Relay. And in my role, I'm doing standardization work on AMQP, on cloud events.
Gotcha.
And I'm also kind of the product architect, if you will, for all those services.
Gotcha.
And I'm Christian Wolf. I'm the product owner of Service Bus, so I own it from a business and a feature point of view.
So why don't we talk a little about Service Bus? I mean, I know that's probably one of the oldest features that we've had in Azure. Probably one of the features we've had since inception, right?
Yes.
Since it started.
Absolutely.
So why don't you tell us a little bit about what is Service Bus exactly? Like, what do we use it for, and what are some of the use cases we might, have that inside of our applications?
Mm-hmm. Good.
Yeah. Well, Service Bus is an enterprise message broker. So we basically have, I would say, 4 different kinds of messaging systems, which we want to talk or touch base a little bit about. And Service Bus is really used for business scenarios where you need high availability, a lot of security, reliability. You need anything like sessions, first in, first out ordering of messages, or you need features like transactions. So whenever you need a guarantee that the data you send from left to right really arrives, and that's when you want to use Service Bus.
Yes.
Yeah.
And it's got, and the features that it has is it has queues, and it has topics. So it gives you the basic ability to go and push data into an intermediary effectively, and then with that, decouple the sender and the receiver from another, so that unlike with what you would do with HTTP, you push a message to a receiver, and the receiver needs to be instantly ready to go and handle it, and Service Bus kind of puts that queue in the middle. And with topics, you get a pop-up feature where you can go and send messages, and then only those parties who are interested in that particular message will go and get it. We have 2, and you can also see that on the slide here, there's 2 queue services, and we often get asked, why does Azure have 2 queues?
Yeah.
That differentiation exists because there are cases where you have just simply that decoupling, and that's the only thing you care about. You just want to go and throw tasks into a queue and want to pull the tasks off and handle them. And then you have other cases where you need to have higher reliability, higher availability, and need to have transactions. You need to have all the features that Christian just mentioned. So Service Bus is specializing on kind of the heavy-duty messaging pieces.
Right. So if you look at these 4 systems, let's touch base on each of them really quickly. Storage queues, that's exactly as Clemens described, like a simple task queue scenario. You want one process to run on 10,000 VMs, you maybe need 10,000 queues for that. You push everything into your queues, and then the VMs receive from that queues and process whatever they have to do. Service Bus is really, for example, you have a retailer, you want to send all your post-transactions orders into the cloud, you want to process them in one way or the other. You maybe want to send them to an ERP system for fulfillment or for replenishment of the retail store. So there's multiple different scenarios you could think of. Service Bus can also be used for web shops, for example. You send all the orders from the web shops, process them, modify the messages maybe on the go, and we'll have actually a little sample for that at the very end. Service Bus is really like when you need highly reliable transport. And then Event Hubs, that is really big data streaming for analytics. You have telemetry systems, you have production machinery which sends signals, or you have web pages or VMs which send signals, and you want to ingest this data and start reasoning about that data. And then Grid is the newest, I would say, kid on the block. That is for cross-cloud reactive programming. It's like an eventing service. So essentially, whenever you have a state change somewhere, or you have something happening and you want someone else to react to it, that's when you want to think of Grid.
So the typically the very coarse-grained from the top, the way you think about the differentiation between the eventing services and the messaging services is that when you use a messaging service, you typically have an intent to send a message or have someone else do something. And with an eventing service, you typically have a fact. So something just happened, and you report that out. So you don't have an expectation for something, so you don't need to have that degree of control, reliability, and making sure that it's exactly once happening exactly once, etc. You don't have those concerns with eventing, and eventing also kind of gives you some, therefore, some different delivery patterns that we have. We control your own cursor with event hubs, or we do a push mode with Event Grid.
Right, so I know some of the times the way I think about it is when I want to pass events, I'm usually thinking of something that's very, like something that's, I'm having a lot of throughput, not really passing a lot of data, like very small packets like coming through very quickly.
Yes.
And when I also think about messaging, I have like some data that I need to encapsulate and send over. I know there might be some deferred communication, right? So like whether the consumer is available or not, like I can send this message.
Correct.
And then whenever those consumers are up, they can now reach into it. But no, that doesn't stop my clients on the other side being like, hey, that consumer's not available.
Correct.
I could send the message and I could keep on doing what I'm doing.
Correct.
And kind of have like this asynchronous deferred type communication going on.
Correct. So we had a little episode from Service Bus when the game Halo 4 launched on that day. On launch day, the entire backend went down.
Oh.
No data was lost, because it all went into Service Bus at the time, and then Event Hubs later for the next version of Halo.
Nice.
And then they could go and process the data out. So it was a complete decoupling of the games that were played and the statistics backend that was at the end, which kind of shows you at giant scale of a game with 1 million players or more.
Gotcha.
That actually helps to keep that system more robust, because the gaming experience was not affected by the system being down for a while.
Right. And Clemens mentioned actually a perfect event hub scenario right now, and he just said that I just want to highlight that fact. That was in the past. Service Bus is obviously our oldest service. We tried to do everything with Service Bus. Now that would be exactly a telemetry scenario. You have 1 million gamers running their games, emitting telemetry, and then you have some point in time you want to reason about the data, and that's classic for event hubs, right?
Exactly.
Difference between event hubs and event grid is on event grid you want to act on the data. On event hubs, you want to reason about the data.
Yes, gotcha. So we've spoken a little bit about the differences between the services, but I'm guessing we've seen patterns where we've used multiple of them together in the same application, right?
Yes.
Is that a common use case that you guys have seen?
Absolutely.
Yeah.
And we're now actually building these things out so that you can go and mix and match them very actively.
Yeah.
So specifically also with Event Grid. The case exists very often that you have queues that are not very busy, but you need them for important events. So you have a queue, the queue receives only alerts, and those alerts should only ever happen, and they're important because you must process them, so you put them into a queue. But those alerts only show up when something very bad happened in the system, so ideally never, but then probably like once a day or once a month. So it might be very expensive to run that handler all the time. Yeah. So what we can now do with the combination of Event Grid and the Service Bus queues is Service Bus queues can now go and raise the grid event that says this queue has a message, but nobody's listening on it. Right. Mm-hmm. And then you can go and listen to that grid event. You turn around, you go to the storage queue and pull that event out, but then process that with the robustness that Service Bus gives you. So we're starting to combine those things. But we very frequently see that customers who need messaging in their applications, who have understood that gives them an architectural advantage, will go and look at all three services or even the relay sometimes and combine them as they need them, because they will typically have all those various nuances of use cases in their solutions.
Right. So with these different services, these different messaging services that we have, so I know there's this protocol called AMQP, right? Is that something that's common across all of these different services? Is that something that I could use and something that we support today?
Yes. So we use AMQP for Service Bus and for Event Hubs. We also have a path how we can pass data now to Event Hubs and to our queues. Using AMQP, and AMQP is kind of our canonical protocol.
Yeah.
AMQP is a protocol that was finalized in 2012 by an industry consortium. It's something that has been started actually in the financial industry on Wall Street. and then eventually joined that effort, and it's now the dominant messaging protocol in the market. We are, I'm in the technical committee at Oasis for AMQP. I co-chair that. And we also developed that further. There's actually quite a bit of activity in the committee to kind of push that forward and enable more and more use cases. One thing that we're particularly working on is a lot of enterprise scenarios are driven by JMS. Java is very broadly used in the enterprise, and they have a messaging standard JMS. And so there's a mapping for JMS is being developed now in Oasis, and we're actively participating in that. We're also helping. We're done basically plumbing all the necessary things into Service Bus to make that really work really well with all the features that are in there. So that's a foundation that we have, and also to accommodate AMQP, we made recently some good set of changes, and we created a new client. For Service Bus, or a set of new clients for Service Bus, and including a new client for .NET Standard.
Okay, great. So one of the things I wanted to ask you is if we're supporting AMQP, so that means that any AMQP clients, right, whether it's made by Microsoft or not, should still be able to work with Service Bus and integrate with our services.
Absolutely.
Right?
That is correct. That's the goal. So we are. You can use today, and there is typically in most of the stacks now, and most of the AMQP stacks now, there are examples for Service Bus specifically.
Sure.
So you can pick up Proton C, which is part of the Apache Cupid Proton project, and do that with C. You can go basically any language that's supported in the Proton project you can use.
Gotcha.
These are kind of protocol cores that you can go and send and receive messages with. And now what we're doing is we're picking up these stacks that we're also helping with, and we're wrapping them to put a bit of a nicer API around them. So and to make a unified API that looks the same. So we've picked that up for Java. So our native Java client, which is not JMS, wraps the Proton J client. We have our native AMQP stacks that then for .NET and .NET Core that are then used by others, for instance by Red Hat. As the primary client for their products.
Got it.
So it's something that is a give and take across the industry now, and a really fruitful collaboration, and it's all anchored around that protocol.
Nice. So you guys mentioned the .NET Standard client that you recently built. So now, and we know there was an old client, right? So, but this new client, because it's .NET Standard, means that it should be able to run a .NET Core, should run a .NET Full Framework, and a lot of other flavors and versions of .NET. So essentially now, we could leverage, everywhere that .NET runs.
Correct.
Right, and we'd be able to work with Service Bus.
Yeah. So we have for instance, we have a new performance sample that we just published. Okay. That is now where I've just wrote the instructions that I'm mentioning it, and I mentioned the instructions for this is how you run this on Linux. This is how you run this on Windows. Because we're now liberated from the tie-in to Windows, and we can go make it work everywhere where the .NET runtime runs. And Christian can actually show you talk about the standard client a little bit and show you some.
So that'd be great. I had two little samples. Once we want to show at the end, but let's start with the first one. So if you know Service Bus and you know the different clients, then you also know, like sometimes, we just made. If you compare them, you will notice we made a lot of effort to make it much easier to interact with a new client. So here a little sample. So you can see basically this is how easy it is to register receive pump. So basically here say, okay, register a message receiver. And at the same time when you do that, you also say where do you want to receive your exception. So you have an exception callback. So you have a lot of freedom of how you treat and act on your exceptions. So this sample is really very blunt and simple. It does nothing but sending and receiving messages from a queue. And you can see so you have two methods here. One is processing the messages, and one would act in case if you would get any exception. And then the last one here is really nothing else but sending a few messages. So let's just run it. Okay. And you will see, sends and receives two messages, but you can see it really doesn't need a whole lot of code. So you need, if you remove the comments, probably some 30, 40 lines of code, right? So
we have the eternal problem of demoing TCP/IP not being very sexy,
pretty much.
because you only send and receive messages.
Sure.
What's noteworthy about here, with the choice that we made here, is that we actually took away. So going to .NET Center, we made a few API changes towards compared to the old client, because the old client had all the features of all the services kind of jammed into one place, and we want to go and break that apart.
Yep.
Then it had significant dependencies on APIs like WCF and other things that we completely took out, and we replotted that completely on AMQP. And we have a lot of, we use that change as an opportunity to address a lot of pain that customers had, or that we had in terms of supporting those customers, depending on how I look at it, because some things were just too hard. So for instance, one thing we do now, and this is what reflects in that sample, is we now no longer have an explicit way to go and receive, imperatively to receive a message on the normal QueueClient. On the normal QueueClient, you say, you register a handler, and then you get called back, and you process that message, and when you complete that message, you're going to get the next message delivered to you. So we're dealing with all the complexities of a message loop for you.
Sure.
If you want that control, you can pop out, and you can use the message receiver. But we just try to keep everybody on the simplest path, so that we're dealing with all the possible error traps for you.
Gotcha. Let me show you two things. Two things. Mention one thing, show you one thing. If you want to go on a lower level, so you don't want that extra comfort we just spoke to, you would need to use like servicebus.core here. You see that. You would add that via using, and then you could go, like, for example, instead of using a pump, you could go to call receive directly and send directly. So these things, just a little trick if you want to use this library. And the other thing is, right now in the old versus the new library doesn't yet have management operations included.
Sure.
We are on our way to include those. They will be there, I would say, by June timeframe.
Sure, so a couple months we'll have that ready to go.
Yeah, that was a long wounded thread on GitHub. That was an issue filed, and
is that issue 65 or
issues, the infamous issue?
Is that
infamous issue 65?
Yes, and so the thing is, we have this. There's this principle in Azure that all the management operations happen through the Azure Resource Management interface. Since our service is old, our management interface far predates any of that.
Yeah.
So we always had kind of management kind of in the service. We took something away, which is very terrible always. We said, well, there's a way you could do this over here. And then customers came with, somewhat expectedly, with a lot of use cases where they said that's not a fit.
Got it.
So we had the namespace manager, however, that we're replacing was a little bit unwieldy and large. We're making this a much more focused thing. We say we really make a razor sharp focus on the exact use cases that people need to have that dynamicism for, and support those.
Got it. So hopefully when that happens, it'll be a lot easier for people that are using, I guess, the older client that is used to that type of behavior. Now it'll be easier for them to come over to the new client.
Correct.
And have like the same type of behavior from using that NuGet package.
Correct. Yes, that's right. But in general, from a philosophy perspective, we believe that your topology that you're using in Service Bus should be something that you consider part of your deployment, and that you then use these dynamic entities sparingly.
Okay.
And we're trying to reflect that philosophy in the API.
Right. Gotcha. So one thing I wanted to ask you, so I generally am an ASP.NET developer, right? But develop a lot of web applications. So when you think about the requests, right? Like the lifetime of my request is usually very short versus like a desktop client.
Right.
So when we were working with the Service Bus client, is it recommended that we use it like in a singleton type pattern, try to keep it long lived, or is it something that is very transient and do I recreate one every time? Like what's the best advice there?
So we do some magic under the covers to make it not matter all that much.
Okay.
Because we use connection pooling.
Okay. Great.
But generally, AMQP is a connection-oriented protocol, and you're creating when you have a QueueClient. You build a relationship with the server, which means the first operation, you do something, you create the connection. The client then holds on to that connection. So you should go and treat that as a resource in your application and protect it. It is thread safe, So it's not a problem if you have a QueueClient and then use that for multiple threads, even at the same time, because it'll be fine. So we're dealing with that for you.
Okay.
So you should think of that as a singleton, effectively, that you use once. And once means you should be a little clever about it. If you're building a giant monster that does several thousand requests per second, then you should be a little smart about it and probably do a client on a per session basis, client on what a reasonable scope is.
Sure, I got you. So another thing I want to talk about a little bit about Service Bus. So I know there's almost two flavors of Service Bus. Right? There's a standard version, there's also a premium version.
Right.
So me as a developer, could you tell me a little bit about the differences between what I get from standard and premium? What's the value add of me moving over to a premium model?
So the premium Service Bus is really for production workloads in the sense where you. This is where we add all these features, like, for example, recently we just added metadata GeoDR. We are adding data DR there very soon.
Right.
These are things we really reserve for our premium tier. They will not find its way to standard. So if you are either a big insurance company or a big retailer or a car manufacturer and you rely on Service Bus and you need geo data recovery, right, or geo metadata recovery, then these things will never be in standard. So you can build these things semi on your own, right? But
that's work and that's effort.
It's
and
a lot of work
I have
on
to
your
maintain that myself.
Right. A few other key differences are, for example, things like IP filtering or VNet, which we're just implementing right now, or also later we are planning a feature called Audit Trail. All of these things will be on the premium tier, right? So all of these things which you really need in enterprise messaging will never find its way to standard.
Yeah.
Standard, I think I would see it as like an entry-level SKU. You can use it to code on, you can use it to test everything. For very low volume scenarios in production, you could use it. Whenever it is about production and you want high availability and you want guarantees for throughput and you want repeatable performance, then you should look into premium.
Sure. So like you're saying, so if I get premium, I get like that guarantee in terms of that disaster recovery. I'm sure I'll probably get more throughput.
Availability zones will be there, for example. We are implementing that right now. So all of these things will be on premium. We are not building it for standard. Right?
Gotcha. So if I was supposed to use standard, would that be good for me to build something like, I don't know, like I had a simple task queue or something like that? Like could I use the standard version for that?
Yeah. Theoretically, you could do that, and the session feature, so a matter of fact, helps a lot with that, because see a session like a sub queue, right?
Yeah.
So you can use that to split your workload for the regarding tasks. I would think storage queue might be better for a pure task queue scenario.
Would you? Okay.
But you could use Service Bus for that.
Yes. Yeah. So what would you say that? So what would you think? So what is it about the features of storage queues versus Service Bus that might make you feel like that might be a better solution for that?
In storage queue, you can have easily more queues.
Okay.
And it is very lightweight, right? If you look, for example, at the storage queue, the message doesn't have headers. It's a pretty simple format, right? And task queues, typically what you need is very simple, right? You just need like, hey, I want to park my task till the other side is able to pick it up.
Gotcha. So I don't need some of those features like filtering and disaster recovery, geo-replication, things of that nature.
And you very often have the duality of, and this is why it's kind of associated with storage, is that you are throwing a job represented by some file into a blob store, and then you say, please go and process that someone. Gotcha. So it's logical that, like, if you already have a storage account, you're in the storage account, that you're storing that file, and then you're putting a task into the task queue that goes and processes that.
Got it.
So it makes sense for a lot of those scenarios where you have something that's literally just a simple task you want to go and fan out to a bunch of workers.
Sure.
For that, that's ideal. And then once you get into more sophisticated scenarios, then you are landing automatically, more or less, in Service Bus territory.
Right. So like when I wanted transactions and rollback and things of that nature, that's when that will come in.
And scheduling, and there's 1,000 features that we have, and then you have AMQP support, obviously.
Right. Sure.
For interoperability. So there's a lot of reasons even to use standard. What you get with premium is really predictability, because the resources associated with a Service Bus premium namespaces are yours. They're reserved for you, ring-fenced for all the time.
Got it.
And with standard, you get a shared pool, and if lots of people are busy, on the same cluster where you live, then you're getting less time.
Gotcha. So did you want to talk about some of these features that you have up here?
Very briefly walk through it. So on Service Bus, one of the features, scheduled delivery, so you determine when the message should be actually enqueued. Dead lettering, so after a number of retries or after a number of failed attempts, the message gets dead lettered. We never lose a message. We just move them to a dead letter queue for you to inspect it later. Forwarding, so you can determine between, you can say from this subscription to this queue, I want to auto forward. Then deferral, this is like a workflow-oriented feature where you could say, oh, this message came to me out of order, I want to put it back and I want to just process it later. Sessions, imagine it like as queues and queues, right? Like little sub-queues, very lightweight. You can basically use that to enforce first in, first out order. Batching and long polling, meaning this is, we talked before, as Clemens mentioned, event grid, for example, is allowing you to do pushing instead of polling. So treatments there for Service Bus are two. We integrate with event grid. And the second one is we allow you to do long polling. So you open a connection to the broker. If there's no message within 60 seconds, right, then only then we do another request. So we request only every 60 seconds. So classic long polling there. Batching, you can send multiple messages in one go. Transactions, so basically it's like if anything fails, roll back. Filtering in actions, so you can basically apply filters, and that's actually the last sample I have for us today, where you say, oh, you processed a message, it has some certain criteria, and now I apply a filter and I send it somewhere based on that filter, and then auto-delete on idle. So that's a subscription which never would get messages. You could delete it or have it auto-delete. It's a little dangerous feature. Duplicate detection, that's based on the message header. So if you get 2 times the same message header, we would detect it within a certain time span. Then role-based authentication and MSI support, that's in preview state right now, but it's going to ship very soon. The geo-recovery we talked about. Developer cross platforms, we talked elaboratively about. So we are very open source supportive. And then on the right-hand side, a few of the integrations. I said right now with Azure Event Grids, we have very tight integrations with Logic Up and Functions. And Dynamics 365 for sales actually also is a pretty solid integration story with us.
Cool, that sounds pretty good. How about we just take a look at the demo that you have and take a look at some of these features?
So that is a demo which shows you, I get like a message from some web shop on the left-hand side. It just, it basically sends a message. It comes more like a very blunt, no headers message. So you need to process this message in the one or the other way and figure out, what's going on in there. And then you basically reroute it for further processing to a subscription. That is the second part here. And then on the way of doing that, we also apply some filters. Let's just go into it.
Let's take a look at the code.
So that's basically the sender code. So what we use to run it, we can start it actually right now. It's just like I made it into some Azure functions which just keep sending messages just for demo purposes.
Okay, so hold on 1 second. So your Azure functions has a Service Bus client in it, and it's going to be sending messages to a queue somewhere.
Exactly.
Okay.
Exactly. So I have 2 functions. One is just sending, and one is receiving and then sending to a topic, basically. So I show you both. I show you a queue and I show you a topic with subscriptions.
Okay, so I don't think we've talked about it, but so really quickly, could you tell me, like, what's the difference between a topic and a queue inside of Service Bus?
So a queue is really like, I think the industry term is a message channel, where you would say it receives and sends messages, one inbound, one outbound. And then a topic is like pops up.
So I can have multiple folks listening to the same topic.
So you have a topic and then n subscriptions for the topic. And then you can have each subscription gets a message, basically a copy of that message. And then you can have filters on the way between topic and subscription and rules and actions. So you can create a rule which has like a filter. So if that applies, do that action and then basically move it to that subscription.
Cool, sounds good.
So let me just start it up. So we have something to look at, and this is basically how everything looks like under the hood. So here's my queue. That's where the stuff will be coming inbound, and then we have basically my topic here and 2 subscriptions, and we have basically a high value and regular sales here. I called it like that. All my code is doing really, it sends first to this queue, it sends a message like containing only 2 fields. Obviously, it's just a simple sample. And that's one-time JSON. Sorry, that's just the customer, and then the sales value, some random sales value. And then basically here, that's an interesting thing because Clement mentioned the old client and new client quite a bit. So if you want to interact between multiple service bus clients, you typically want to send a memory stream. You don't want it just directly serialized into JSON and then a byte array, but you want to use a memory stream. So this code is kind of a typical example how you would do that.
Got it, yes.
And then on the other side, we receive that message. Basically, we receive it in batch. So we mentioned the feature batching. And then we basically, instead of keeping to send just the body, we add some header. We say, oh, let's add the header sales value here. So my system, which is then late at the end processing the message further, can react to that sales value. And let's see if that all works. We got a few messages here. We got a few messages here. So the function basically started pumping, going in here, and then you can see we have the filters here which say, oh, I have a high value sales. I want to treat sales which are more than $10,000. I want to treat them different than regular sales. So you have the opposite filter basically.
Yeah, and that's something that's been processed by Service Bus. So you send a message in, the message has that header. Service Bus never looks at the message body, so that's something that is effectively protected and we never look at it.
Yeah.
So what Christian is doing here is he's taking a message in, he's promoting effectively some information that's out into a message property, and we can then go and take a look at the message property for routing purposes as he does here.
Got it.
And the cool thing is you don't have to write any code for the actual promoting of that.
That's right.
That is all Service Bus. So.
Cool, that sounds pretty good. So if we wanted to take a look at the sample, is this on GitHub somewhere? Can I look at this, or are there other samples that we could take a look at?
So this particular sample, not yet.
Okay.
It's fairly new, I just wrote
Is
it.
it private?
I will actually put it on GitHub, and it will be exactly on the same place where I show you right now. So this is our standard GitHub repo. It's Azure/Azure Service Bus. And then this would get you to the .NET client, that would get you to the Java client. Here's our samples, also grouped in .NET, Java, and management. So all kind of management operations or sample for AAD management operations you can find here. Samples how you could consume Azure Metrics, the monitoring metrics pipeline. And then here you have all kind of samples for the old client, for the new client, something very more the primitive samples to get started. And then also the perf sample Clemens mentioned before, I also linked to it here. So you have that available too. And then interesting, also Clemens mentioned, or you actually brought up the question, we would support JMS, or wherever when you speak AMQP, right?
Yeah.
Then you can interact with Service Bus. So we have like a JMS sample here. And yeah, we have more like Service Bus samples in here for Java. So
and we've got samples coming for, so we have brand new clients coming, brand new implementations that we build of AMQP,
Sure.
and then putting clients on top of it for a number of additional languages. So that's all in flight, and we're making those things better. You can use Go, Python, etc. already today with the Proton client, but we were creating officially blessed and then Microsoft supported API wrappers around those.
yeah,
Cool.
And sometimes completely new AMQP implementations.
Great. So that if I wanted to get started with Service Bus in .NET or in Java or other languages, I could effectively come to this repo. I could take a look at the samples.
Yeah.
I'm sure we also have really good docs at docs.microsoft.com that we could take a look at too.
We do.
So if you go to docs.microsoft.com and then Azure Service Bus messaging, you have basically overview, what is Service Bus, some fundamentals, and then a few quick starts where you can say, well, this is how you use queues, this is how you use topics and subscriptions. And then from there, these links here, like if you follow these samples, you see also we have it for multiple languages. So the news will be Go, then a new Node library, a new Python library.
Sure.
And then, from here you will also get to GitHub.
Great. Well, this is great. This is a good start. I kind of feel like we have so much more we could talk about. So we're going to have to have you guys come back on again another time
Anytime.
and talk about
We'd
this.
gladly do that.
That would be wonderful.
Thank you.
That's great. So here we have it. That was another episode of the On.NET Show. We learned all about using Azure Service Bus.